Hi, we are glad that you are here on Jaman's MATLAB coding. In this digital image processing episode, we'd like to talk about how one can design a noisy digital image in MATLAB. What is a noisy image? A noisy image is basically a two-dimensional intensity function just like the image. Say the noise is g of mn, then values of g or noise values are random. Any value can be equally likely for the noise, and the noise value is also unpredictable. We cannot predict with certainty. Maximum noise image intensity value is completely user chosen, which is related with noise strength compared to the original image. Viewers need the background of clip 64, which illustrates how to display a digital image, and clip 67, which illustrates how to design a single color image in MATLAB. We would like to design a noisy image of pixel size 200 by 200. In MATLAB, there is a random number generator which is rand. Rand receives two input arguments. First one is row number, second one is column number. So rand 200, 200 gonna generate a matrix of size 200 by 200, or you can say image size pixels. Now return of rand is any number, decimal number of course, between 0 and 1. For example, the rand return could be 0.55, 0.72, 0.91, etc. We also assume that data storage of the noisy image is in unsigned 8-bit format. We mentioned in the previous slides that for unsigned 8-bit format, maximum integer value the pixel can assume, or intensity value the pixel can assume, is 255, between 0 and 255. So that's why we multiply the return of rand by 255. So any value between 0 and 255 is equally likely for every pixel in the random generator. But the fact of the matter is the return gonna be in decimal. For storage reason we need integer. So we have to convert the decimal to nearest integer by command round. So round of f gonna return the value from decimal to nearest integer, and which we assign to workspace variable fr. Now for storage reason again we cannot keep the decimal integer, we have to convert decimal integer to storage integer, and which happens by uint 8. So we use uint 8 over fr, and return we put in the variable fu. In the end we're gonna display the data stored in fu by info, and these variables f, fr, fu are all user chosen. You could have used other variables of your choice. The random number generator rand has some statistical implications. In image processing literature, rand has link with statistical definition. We call it IID, or identically independently distributed random number. It has also another name which is called uniform distribution. That means any pixel value, the intensity value inside the image, is equally likely. Meaning if it is between 0 and 255, some pixel value can be 25, some pixel next, the pixel next to it can be 0, pixel next to it can be 100, any value equally likely. And there is also another fact here, noise strength. We assume that image intensity, which is between 0 and 255, and noise strength, that is also in the similar range, which is also between 0 and 255. Successful execution of the previous slide's command must show you the image as seen on the slide, which is 200 by 200 in pixel size, and this image has some specific name in image processing literature. This image is called salt and pepper noise. That's it for this session. Thanks for sticking around. Do not forget to share, like and subscribe our contents. I hope to see you in next clip. Bye for today.